Hi, and welcome back to the channel. This week's problem is about finding the shaded area inside of this shape. We have got a quarter circle and a right triangle, okay, right angle triangle, where the right angle is at the point O. Now S, which is on the hypotenuse of that right angle triangle, is a tangent to the quarter circle, and the shaded area is that right triangle subtract that quarter circle. P to S has a length of 2, S to Q has a length of 8. If you think you can solve this problem and you want to have a go yourself, pause the video now. Otherwise, I'm going to go through my solution in 3, 2, 1. Okay, so I'm going to show you a couple of ways of doing this, but the first method is probably the one that most people would have tried, or if you were able to solve it, probably used. Now, the first thing I'm going to do here is I'm going to put a radius on, so from O to S, and that's going to have a length R. Now, I know that is going to be perpendicular to the base because a radius meets a tangent at 90 degrees. Okay, right, now from there, I can start labeling the angle. So I label this angle at P as theta, and then because I've got a right angle, PSO, so the other side of that right angle I've labeled, I know that this angle at O is 90 minus theta. Now I know the full angle in that triangle, in the triangle POQ, is 90 degrees. So I know the angle here, SOQ, has to be 90, subtract 90 minus theta, so it has to be theta. Now, that then means that this final angle at Q has to be 90 minus theta. Now, from there, I've got two right angle triangles, smaller ones, inside of that larger right angle triangle, POQ, which have got the same angles, and therefore, because they've got the same angles and they're right angle triangles, well, because they've got the same angles really, they are going to be similar shapes, okay? So what I'm going to do is I'm going to take those similar shapes out and I'm going to reorientate it so it's easier to see the corresponding sides. Now, because they're similar shapes, those sides are going to be in the same ratio, or they're going to have the same scale factor from the smaller one to the larger one, or vice versa. So I know that if I do 8 divided by R, so the larger side divided by the smaller corresponding side, that would be the same for the other corresponding side. So 8 divided by R will be equal to R divided by 2. Okay? This 8 here and this R here and this 2. I can then rearrange that equation. So cross multiply, I'm going to times the R by R and 2 by 8. And I get 16 equals R squared. Now, when I say cross multiply, really what I'm doing there is I'm timesing both sides of the equation by R and at the same time, both sides of the equation by 2. So really, you could say I'm timesing both sides of the equation by 2R. Okay, so we get 16 is R squared, which just focusing purely on it as an equation, when we square root both sides, gives us plus and minus 4. However, we are looking at the radius as a length. It is a length. So the radius has to be positive 4. Okay. Let's go back to the original diagram. Let's put on the radius of 4. Now, I said at the start, to solve this problem, really what we need to do is work out the area of the triangle and take away the area of the quarter circle. Well, the area of the triangle is going to be half the base, which is 10, times by the perpendicular height. So a half times 10 times 4. That gives us an answer of 20. Okay. Then what we need to do is we need to work out the area of the quarter circle. So it's going to be a quarter times pi r squared. A quarter times pi times 4 squared gives you an answer of 4 pi. And so that gives us a final answer, the shaded area, as being 20 minus 4 pi units squared. Okay, super. If you got that, well done. Now, I'm going to show you another method, which I think, actually, I prefer this method, although I wouldn't have seen it maybe straight away. Maybe some of you did. Let me know down in the comments below. So, I've deliberately made this diagram slightly smaller because what I'm going to do here is I'm going to put this onto an axis, a grid. And you could do it this way, and you could do it with equations, which is why I've used the axes. But actually, you're going to see you don't need to have these axes if you do it the other way. So if you do it without equations. Now, you'll notice there I put a circle around it. The reason I put a circle around that shape is because I know that a right angled triangle will always fit inside of a semicircle, and the hypotenuse of that right angled triangle will be the diameter of the circle or semicircle. And then the right angle will be on the circumference. So the right angle is at O, that's on the circumference. Now from here, we've got two options, okay? What I could do is, well, what I need to do first of all, is I need to find the center of the circle, which is going to be the midpoint of the diameter. So it's got a total length, that diameter of 10. So by half the 10, I get 5. So we get 5 either side. So P to the center of the circle is 5. Likewise, Q to the center of the circle is 5. That gives us a radius of 5. Now from there, what we could do is we could use the equation of a circle. And so the equation of this circle would be x minus 3 all squared plus y squared is equal to 5 squared, okay? And then we could solve that and find where that would intersect with the x-axis, and that would give us the coordinates of O, and we could proceed that way. So you could do it that way as well. But actually, what we could just do straight away is draw this line here, which goes from the center of the circle to that point O, and that's a radius, so it has to have a length of 5. And then you've probably seen we've got a right angled triangle here from O to S to the center of my large circle. So because that's a right angled triangle, I can use Pythagoras to work out the length of O to S. Square root of 5 squared minus 3 squared. That gives you an answer of 4. So we put that on the diagram, and then we're at the same point as we were with the previous method. So area of the triangle is a half times 10 times 4, which is 20. Area of the quarter circle, which is a quarter pi times 4 squared. 4 pi, which gives you a final answer, once again, of 20 minus 4 pi units squared. I hope you have enjoyed this video, and let me know which of those methods you used, or if you use a different method down below. Maybe you did a slight variation, maybe you used equations like I said, and you use an axis like this, or maybe you use some vector method. Let me know down in the comments below. And all that's left to say is thank you very much for watching. If you're not already, please like the video and consider subscribing to the channel. Thank you so much for watching. I will see you next Monday at 5 PM for another problem solving video. Until then, bye bye.